Alright, good day everybody, wherever you are. I'm so happy and I'm so excited to be bringing this to you. It's a very big package from CMRC, Creative Mind Real Concept, and I'm most privileged to be the innovator, the initiator of this program. It is a very big success to bring this to you, Free Success Project 2025. And this year, I am so happy. We have amazing facilitators, persons who are selfless, who are passionate, who are explicit in every ramification of their discipline, and they will blow your mind. So I want you to keep your tabs and start watching these videos and get excellent results and come back to tell us, and we'll rejoice with you. God bless you.
Good day, fellow students. My name is Folayemi Halleluyah, and I will be taking you physics. Firstly, I would like to tell you that physics is part of the course, part of the subject in JAMB that you need to be very accurate, and you have to be very fast. Now, I'll give you a bonus in the beginning of this lesson and the end. Now, the first bonus is that now I structured an acronym that says WETMEM. Now, the first M, the first W is waves and optics. The second letter, which is E, is electronics. The third letter is thermodynamics. The fourth is mechanics. The fifth is electricity and magnetism. And the last one is modern physics. Okay, so now let's structure them. The first one, which is waves and optics, is all about the reflections, the refractions, the sound waves, and the likes. The second one is electronics. This is talking about the semiconductors, the insulators. These are the last part of the textbook, of physics textbooks. The third one is thermodynamics. This is talking about the heat, the temperature, the energies. Yeah. The fourth one, mechanics, is about motion. Now, motion is one of the voluminous part of physics that is about, about the first law of motion, the second law of motion, the third law of motion, and so on like that. And E is electricity and magnetism. This takes a larger proportion in JAMB, especially physics. And modern physics, which is about all this atomic physics, nuclear physics, and so on. So, as an experienced man, because I had 99 in my physics, and I will tell you that physics is one of the kind of subjects in UTME that you can have 99. Is actually very true. I know of some people that have like 99, 95, and so on. So I would like that you are not afraid and you focus on physics very well. So now let's go to the main thing. The first subtopic is state of matter. Now, when I say state of matter, it's talking about the state that a matter can be at any point in time. Now, according to from secondary school knowledge, we know that we have three major states of matter. We have solid, we have liquid, and we have gas. So now, solid are like, for example, this is a solid. For example, a book is a solid. For example, a marker is a solid. And what about liquid? Your liquid is water. Water is the liquid. Your Big Cola and the rest. What of gas? Gas, we have, the funniest thing is that gas, there are many. You have all these nitrogen, oxygens. You have, your mess is also a gas. So, and also we have some type of state of matters too. We have antimatter, we have plasma. They are those ones that they are not stable. So now to focus on the characteristics of the three major states of matter, we have solid. Solid are like, the first characteristic of them is that first characteristic of solids, they take a definite shape, they take a definite volume. In the sense that now, when you go to all this naming ceremony, when they give you rice and they give you takeaway, realize that when you get home, realize that the rice would have formed a particular shape. So because rice is a solid, so that means that rice can a solid can actually form the shape of the container. And also volume, in the sense that okay, you can calculate the volume now. So realize that okay, maybe a cubic plate. So realize that if it have formed a cubic shape, so that means that you can actually calculate the volume. So the volume is what is definite. What about liquids? Majorly, liquids majorly they get the definite shape, but no definite volume. These are some part of physics that they usually ask, and it is a bonus question that you can actually have to your that can boost your mark to 90, 80. So second thing is that liquids, they have fixed shape. Now if you pour water inside the plate, now at that particular time when you are watching, like maybe the glass is transparent, you realize that the water would have formed a particular shape of the glass. So that means that water can actually can form the shape of the container, but it can never form the volume, because if you pour it out, then it would have what? Dispersed. So that means that water can have a definite shape but can't have a definite volume. Now to the last one, gas, because that's not really our main focus. Now gas do not have no definite shape and what? No definite volume. No definite shape and no definite volume, and high compressibility. Now realize that when I'm talking about all this pump, like bicycle pump, they will say they want maybe your bicycle tire gets deflated, and then you want to pump it to gain the shape back. So they realize that the people that pump it, they will be doing something like this, because it's what they want to expel the gas inside the pump to the tire, to the bicycle tire. That means that gas can be compressed, but you cannot compress solid. If you want to compress it, you have to destroy the particular material. But you can compress a gas, you can compress a gas, yes. And also when, for another example is that maybe when you are inflating the balloon, you can realize that when you are inflating it, the more you inflate, the more it becomes bigger, and when you compress, and you can compress it back, So that means that a gas can be compressed. They have high compressibility. Most students don't really know this characteristic. That's why I input it here, high compressibility. And for physics to be actually interesting, you have to know some practical example, real life world examples that can make it stick and can make it more clearer. So now let's go to the second subtopic, which is kinetic theory of gas. So now kinetic theory of gas. Now some part of physics questions, they call them word problems here. Word problem in the sense that they will be in a statement, yeah, and they will give you options. So most students don't really usually get those parts very well, because they just love the calculation part of physics. And let me tell you something, that you really have to know the word part of physics too, so that you're able to balance everything out and be able to get very high score. So now the kinetic theory of gas is a word problem part of physics, and they have five major features, or let's say characteristics of the kinetic theory of gases. And then let's roll. Okay, the kinetic theory of gases. The first and foremost is that what? They undergo what we call random motion. Now, I forgot to tell you something under properties of solid. When you eat a solid, they vibrate about their mean position. Yeah. When you eat maybe a stone, when you eat it, a stone cannot be moving around, or maybe on that surface, unless the surface is not balanced. You realize that they vibrate around their mean position. But when you eat a gas moves around. Like, okay, for example, now when mommy is cooking inside the kitchen, you realize that, okay, the more they intensify the heat, the temperature, you realize that there will be aroma. The aroma will be moving from place to place. So you realize that even if you are beside the house, if you are not really inside the house, you'll be smelling the aroma. How? Because gases undergo random motion. A motion that is not definite, is not it's not directional. It's like a random motion. It's like it's called haphazardous motion according to law of motions. So now let's go quickly. Another one is that what? They collide elastically. Yes. What's elastic motion? According to fishes, we know elastic motion to be what? To be motion that that maybe when there is collisions, the first thing is that what? There is conservation of kinetic energy, and second thing is what? Conservation of what? Of momentum. So whenever you see elastic motion, you must always remember that is what? There's conservation of what? Of two things. The first thing is what? Is kinetic energy, and the second thing is what? Is momentum. So that means that what? When two gas, when they collide, they scatter anyhow. And it says that they will just be exerting pressure on themselves. Okay, maybe in a box now, in a box there is gas, and maybe you exert pressure. Oh, I don't know if I can cite a good example here now. Okay, now when you are boiling water, and you heat the temperature, you realize that okay, there will be steam, and you know what causes all those doubts is that the gases molecules, they are colliding elastically. Because it is not like inelastic motion, which is that there will really be conservation of momentum, but there will not be conservation of kinetic energy. So the kinetic energy before the collision must be equal to the kinetic energy after the collision. That's why you realize that gases, they are very fast, because the kinetic energy is what is always conserved. So now let's go. Okay, the next thing is that what they possess negligible volume. Okay, now you realize that now when we let me cite this simple example. When you want to weigh something, maybe when you want to weigh solid, and then compared to when you want to weigh this is a simple explanation, compared to when you want to weigh a liquid or a gas. Now realize that their weight is not the same. You cannot compare the weight of a gas to the weight of a solid. Realize that the weight of solid is what? Is far more heavier than the weight of a gas. Now let's now assume that what there is there are 2 or let's say 5 molecules of gas in a particular box, and then 5 molecules of solid in a particular box. Realize that what the volume of the solid will be far more significant compared to the volume of the gas. Yes. Now, for example, now in a classroom, when you weigh 5 people in a particular room, because the weight of a building is actually very, very large. Yeah. Now, when you now weigh 5 people with that particular weight of the building, realize that the weight will be insignificant. So that means that this also is like it's also applicable to this. They possess negligible volume compared to the what? I'm supposed to complete this. Compared to the continuous volume. So now that means that what? Even though there are 1,000 molecules of gas in a particular container, the total weight of everything will still be negligible because of the fact that their weight is insignificant. Okay, another one is that what? The average, this one is the simplest. The average kinetic energy is directly proportional to the temperature. The average kinetic energy is directly proportional to the temperature. So this is the simplest assumptions of kinetic theory, in the sense that what? Okay, when you eat a particular gas, the more you eat them, the more they move. It's talking about the more the temperature, the more the average kinetic energy. What's kinetic energy? Kinetic energy is energy that deals with motion, like you are moving. And what's temperature? Temperature is the application of heat. Yeah. So now when you apply heat to a particular to a gas molecule, realize that at that point in time, the more you eat them, the more they move. Yes, the more you eat them, the more they move. So that's telling us that okay, let me cite that use for example. Okay, diffusion according to biology. So that's telling us that they said gas move from a particular region to another, but you have to exert a particular temperature for them to move from a particular region to another. Now realize that also when you want to fart, realize that you're actually applying a particular pressure, and pressure is directly proportional to temperature, and temperature is directly proportional to pressure is actually inversely proportional to temperature, but temperature is directly proportional to average kinetic energy. So majorly, that's the major kinetic theory of gases. And then let's move to the thermal expansion, which is our main focus today. These are bonuses because I realize that most students, they don't really focus on this part, and I realize that they do come out in UTME. So rounding up, I would like to give you the last minute video bonus, and it's like what? The first mnemonics is ASIS, and it's talking about expansivity. A is for aluminium, C is for copper, I is for iron, and S is for silver. So this is telling us that here aluminum has the highest, this is in decreasing order. Aluminum has what? The highest expansivity. Copper has the second, iron has the third, and silver has the fourth. Now the second bonus is for conductivity. My mnemonic is Agnes caught Orphe. Agnes caught Orphe. Agnes, this silver now. So this silver, caught copper, Hall is like aluminium, and F is for iron. So also in decreasing order. So now you don't need to cram all this and mind you, I think there are many more, but you can just know this: Agnes caught Orphe, Agnes silver caught copper, A aluminium, F iron. So that means that silver is the most conductive metal. Yeah. So but because it is very expensive, that's why they usually use copper. Yes, for our electricity we use copper. Then we use copper. Silver is actually the best, but because it is very expensive, we use copper. So you can know that too, and take care. Our next video will be moving on to thermal expansions, which is the main focus and also very very critical part of thermodynamics. Thank you very much.
Be sure to link up with us, message us, seek out our email, send us messages for further questions and mentorship after you have seen these videos. I'm very happy to say this again, that it's a time for you to move on and succeed. It's a free success project 2025. Bless you everywhere that you are. Again, my name is Emmanuel Aderoju Adeyemo from Creative Minds Concept.